This video is about Lab 5, which is the final lab for the Georgia Tech's physics class. I chose to do mine based off of what we did in Lab 2 involving the constant velocity of a falling object, but changed it to see if I could find the terminal velocity of a falling object based off what the graphs showed me from finding the constant velocity. So what I did was I changed up the object and basically did the similar coding and calculations that I had to do for Lab 2, and then just took that final information and calculated if a volleyball falling at terminal velocity was enough to kill somebody if it hit them on the ground below. This slide shows the principles and formulas that I used to find the constant velocity. In order to find the constant velocity, I used Newton's second law as well as weight force, and to find the terminal velocity, I used the formula shown at the bottom of the slide. Here we have the video that I used to put into Tracker, which is me dropping a volleyball in my dorm. I've inputted that into Tracker, and then on the right side we have the video model that is taken from GlowScript, which uses computer calculations, versus Tracker that uses human calculations. So there would be some difference that you would expect because of human error. So in order to get the computer model from GlowScript, I had to use this code, and where all the red lines are where I had to make changes from the original starter code, including updating the mass, changing the B on the left side to include air resistance, such as drag, as well as updating the net force calculations and the ball velocity and ball position calculations. Here we can see the GlowScript graphs that I got after running the code. The ones on the left show the position over time, and the one on the bottom shows velocity over time, as seen in the velocity graph. Once it reaches a certain velocity, it pretty much stays there, and that signifies that it's reached terminal velocity because it's not getting any faster. And the graph on the right side shows the mass of the object over time. And the reason why all these are pointing down is because I made the origin at the center of the volleyball at the start of the video, so it started at the top, which means the ball falling down would have all negative y values, which is why both the position over time and the mass graph are both going in a negative direction. Here we have the final graph that I got by comparing the position and time from Tracker that I did by hand to the times given by the GlowScript code. As you can see, the GlowScript one is vastly different than the Tracker, which would make sense considering that the Tracker is done by hand, which would account for human error. And here we can see the calculations that I did in order to find the terminal velocity of a dropped volleyball. You can see all the information that I inputted as well as the formula used, and my resulting terminal velocity of the volleyball was 0.159. And so in conclusion, based off of all the data that I have shown so far and the final velocity that I got after running everything through the terminal velocity formula, I have come to the conclusion that a volleyball would not kill someone no matter what height it would be dropped at. There is a chance that it could very much hurt as well as possibly break a bone, but it would not kill you. However, if I were to predict what would kill you, I know that it would have to be an object that had at least greater than a volleyball's mass. Otherwise, it would not kill you if it was less than the mass of a volleyball.